Right, so my name's Andy. I am English and I live in Finland, so I get weirded out by the English accent anyway now, so this is even weirder. I work for a software consultancy called Reactor, so if you want to do React development, unsurprisingly, come and have a talk to us. So I want to talk about software security and how we can make things much easier and secure at the same time. Now, when people talk about software security, this is usually what they picture. Someone coming in and saying, no, you need to stop doing that. You can't do whatever you want it is because it's not secure, and they just come and make your life harder. And I'm going to try and show you that you don't have to make people's lives harder to make software secure. Secure? I think secure is a word. I'm not sure. We'll say it is. So normally, you've got on the spectrum of things, you've got easy on one side and hard on the other side, and secure is definitely on the hard side. But hopefully by the end of this talk, you'll see that secure can be on the easy side, and we can try and push people into the pit of success. So if something's easy to do, someone's going to do it. And if it's also secure, then they're going to write secure code by default, and then you'll have less problems, and you won't end up on the front page of the newspaper or being tweeted about by Troy Hunt for being boned, which we want to avoid. So I'm going to talk about how, in previous companies that I've worked at, how we migrated from having a more complicated system to having something that was more secure, and I'm going to even try and do some live coding, because why not have a sense of danger in your life? So the original application that we had was a monolithic code base. It contained, by the end of its lifetime, the end of when I left, there were about 16 websites, 4 desktop applications, and 15 or so services, all running off the same code base. They used a database and a queue, and one gigantic config file to rule them all. Which is nice, because everything's in one place, but at the downside, it means that everything shares the same connection string, which is not great. I mean, the connection string could only execute stored procedures, which meant that we were using stored procedures, which was not fun. And because this was also a desktop application that all our internal consultants used, the connection string was on their machines. So we encrypted it at least so that no one could read it, but the decryption key was in a shared library, which was also on their machines. Luckily, they're not computer people, so the likelihood of them realizing this is quite low. But still, you can see this is not secure by any stretch of the imagination. So what we decided we wanted to do is ideally get the connection strings off their machines. And if we can't do that, at least try and split things so that different services could have their own connections. And that way we might be able to change one service at a time and make one more secure and just kind of iterate until everything else was done together. Now, how many people here have come across Octopus Deploy? A few people. Okay, so you're probably from the .NET world at least, if you've heard of it. So it's a deployment manager for .NET applications, but they've started branching out to deploying everything. And one of its features is that you can make your configuration files templated. So you can go into Octopus and say, this is the default connection string, but when you deploy this application or when you deploy to this host, replace this piece of data in the connection string. So in this case, we've got a TOML file here because YAML is horrible, and TOML is one of the ways forward. So we've got a connection string for the database, and we've got default values for the host and the database. And then when it deploys the desktop software, it substitutes a different username and password. And when it deploys the worker service, it substitutes a different username and password again. This is a slight improvement, because we can now have separate connection strings in each of the databases, or each of the applications. But the downside is it's still manual. We've got a developer going in and going, right, we have a different connection string for each environment, because obviously you don't want the same username and password in each in all environments. And what they do is they go into SQL Server, and they type in the username and password, and then they type in the same thing into Octopus, probably, and then they deploy it, and it works. And sometimes the passwords don't match. And if you have a dev, a test, a QA, and a production environment, can you guess which environment has the password that doesn't work? It's always production. We even had a password that somehow, when someone copy and pasted, was created with a non-printing whitespace at the end of the string. And of course, someone noticed this in the code file, so they deleted the bit of non-printing whitespace off the end of the string, and suddenly it didn't authenticate, but the passwords match when you look at them. That's the most secure system ever. Just add non-printing whitespace in the middle of a password. No one will ever be able to tell. So while this was a slight improvement, we wanted to improve this even further. So we set out to figure out what our goals for this system are, because just improve things is not a really valid thing to do. You need to know what you're trying to do. So ideally, we wanted unique credentials for each application in each environment, and ideally per user of the system. This was a nice to have, not something we were really pushing for, but if we could get things so that we logged who did what exactly, that would be good. We didn't want any manual steps or scripts. We wanted it to actually be securely stored, which meant not writing something ourselves, because writing your own cryptography is stupid and hard, and you will get it wrong, and then you will be on Troy Hunt's Twitter feed. So don't do it. Use someone else's library. And we'd wanted to have it auditable, so we could look back and see who'd done something wrong. And we didn't want to write any code, because while I enjoy writing code, if I can write less code, that means there's less chance of bugs, and less chance of bugs means I can be more bored, and I like being bored. It gives me more time to drink coffee. And I don't like solving bugs. I'd rather not have them. Luckily, there is a piece of software, which the title of this talk probably gives away. It's HashiCorp's Vault. So has anyone here used Vault before? Oh, a few people. That's good. The number of people, when I do this talk, that have used Vault is going up over time, which I think is probably more down to HashiCorp's marketing than mine, but we're going to say it's down to me. So for those of you who haven't used it, Vault is secrets as a service. You can deploy it to your own infrastructure. It comes as a single binary. It's free unless you want support, in which case you need the enterprise version, and that costs, contact us. So probably quite a lot. There are also two levels of enterprise. There's enterprise and enterprise pro. I gather the difference is enterprise is a support contract, enterprise pro is for like if you have a gigantic global organization and you need really fine-grained controls to teams and companies and things. So basically, the bigger your organization, the more you should pay, which makes sense. And if it's free to start with, that's great because then people start using it. It's also FIPS 140-2 compliant, which I gather is the Federal Information Processing Standard. I have no idea what it means other than it's hard to get. So the fact that it's been certified as secure is better than you going, I have heard of bcrypt. I can use that. And then making something insecure with it. It's also super configurable, and you can store data in multiple backends like SQL databases, NoSQL databases, databases that don't use SQL that are not NoSQL databases, because that's different, and Consul as a backend as well. But because talking is boring, I'm going to try and demo some stuff. So we're going to use one of Vault's coolest features, which is dynamic secrets. So this is where we can ask Vault to get us a connection string to a database, and it'll generate one for a short amount of time for you. So rather than having a hard-coded username and password somewhere, we can have Vault generate one on the fly for our specific application. And half my speaker notes aren't visible because my screen died on the flight. There's a nice black effect creeping into the sides. So hopefully this will work. Right. Let's clear that. You don't need to see that. So the first thing we're going to do is set up Postgres itself. Now, Postgres is a secrets engine. We're going to set up the Postgres backend in Vault. Now, the secrets engine for databases can support any relational database, also non-relational databases. That's the NoSQL ones again. And it can also work with things like RabbitMQ, but there's also plugins available so that if you want to write a plugin to make it work with some random piece of tech that is in-house, you can do that as well, as long as you write your plugin in Go, I think. Right. Yeah, sure. Yeah, it's weird. I change everything else to white, but not the console for some reason. Can I do that easily? Color scheme designer, that sounds fun. Not fun. Which one of those sounds light? Rosy Pov, that sounds fun. Right, foreground, black, background, white, and go away themes. Good, thank you. So the answer is no. So I'll just make the text huge and hopefully you can read it. So the first line on that under the script is enabling the secrets engine. That is literally the command you enter, vault secrets enable database. We then write some configuration to it. So we're writing here saying, I want a config called Postgres. It's going to use the plugin name Postgres because that's an inbuilt support one. We're going to ignore the allowed roles. We're going to let anyone use it. And we define a connection string, which is the connection string that Vault will use to talk to Postgres. And then I'm using the super secure username and password for the admin account, which is Postgres. Don't do this in production. Generate a new account that can only create other accounts for Postgres and use that instead. This is just slightly easier to demo. We've now created a reader role. So this is what will happen, what will be executed when your application wants credentials to talk to the database. In this case, you can see here it will run the create role statement. There is a username and password merge field, as well as an expiration time. And then it's got a grant, which allows it to select tables in whatever namespace that we tell it to. And then to show you that we can do a different role, we've now created a writer, which is basically the same thing, except this one's allowed to modify data as well. We'll get back to how this works in a second. Now, here's where I would quite like to be able to read my notes, but there's a black blob over half of it, so let's try generating a credential and see what happens. Actually, let's look at dbeaver. Right, so these are all the users in my Postgres database. I don't know if I can zoom this one. No, I can't. So we've got a bunch of inbuilt roles and the Postgres user, which is the admin account, which I'm not going to rename, otherwise bad things will happen. So I'm now going to ask Vault to read database/creds. And now I can't read the end of my writing, so I think we're going to generate a reader account. Yes, we have. So Vault here has generated me a username, which is this part. Oh, there you are. I can just... No, I can't select all. Oh well. So we've got a username here and a password, and it's got a duration of 10 minutes. So you can only use this connection for 10 minutes. If we go back and look at dbeaver, you can see here we now have our user, and I think if I double click on it, this has changed a bit since I last saw it. Somewhere in here where it used to be, there we are, valid until. So this is valid until 38 minutes. So by the time I finish doing the demo, hopefully this user will disappear. So not only is it setting the expiry on the account inside Postgres, but Vault will also delete the login after that time has expired too, unless you refresh the lease on it. So when we requested the data back, we also got this lease ID, and you can now ask Vault, hey, extend my lease on this particular credential, which will work up until a point. So in our setup for Vault here, you can see at the top of the screen, default TTL is 10 minutes, so that's how long the lease duration was allowed for. And you're allowed up to 1 hour on this credential. So you can keep saying extend this, extend this, extend this, up until the hour point, at which point you need to generate a completely new credential. The idea of keeping the credential short is that if you then end up getting attacked, then your credentials are only going to be live for a small amount of time. So there's hopefully only a small window when someone can steal a database credential and do something bad. So now that we've seen it in the console, which is not particularly useful, let's go and see what we can do in an application. So this is a .NET Core application, because why not? And in here we have a configuration object and a connection. So hopefully, there we are. So we have a Vault client, setup, which is set up somewhere. I don't know why this is scrolling so weirdly. Half my applications scroll naturally with two-finger drag, and the other half scroll the opposite way, and it's really confusing. So we're telling it where Vault is located. Now, if you're using service discovery, it integrates with Consul, so you can ask Consul for the Vault location as well. We're going to authenticate using the root Vault token. We'll cover why this is a terrible idea later. And then we're going to request. So once we've created our client, in this connect block, we say, on the database secrets, get me some credentials called reader, and then we just build a Postgres connection object. And you can see here that creating or requesting credentials is easy. You just say, give me the reader credentials, and then you get everything that works. You don't need to worry about creating the users. You don't need to worry about passwords or expiries or anything else. So a developer coming along doesn't need to do all the setup of Postgres. They just need to request credentials, which makes it easy to do, which means hopefully they'll do it. No guarantees, but that's what code review's for. So if we run this, with luck, we should get some decent output. So this console application is just printing out all of the users in the database with really bad wrapping. So every time I run this application, it's generating a new token or a new secret with a username and password. So you can see this is the one that I demonstrated from the command line earlier because it's going to expire in 6 minutes. And these are the two for me just running now. So it's nice and easy to generate new secrets on the fly. And now we don't need to know about what the usernames and passwords are. Also means that someone can't just go along and connect to the database because they happen to know the username and password and then mess about with data, because no one knows what they are. But I did connect to Vault using the root token, and I said this was a terrible idea, and it is, because the root token can do anything with Vault. It can create new secret backends, it can authenticate things, it can unauthenticate things. We can do anything with it. And if you're distributing your root token around, you're essentially doing the same thing as my first application, which had an encryption key in a DLL next to the thing that it was decrypting. So instead of that, what we need to do is we need to authenticate all of our applications with Vault separately. Now, there are multiple ways to do this. It can support things like GitHub authentication. So a developer on your local machine developing against some development environment in a cloud provider, you would authenticate against Vault using your GitHub credentials. But when you deploy your service, you'll need to deploy this. The service needs to authenticate somehow. The services can use things like AWS IAM or Azure's Active Directory, and then it supports all other manner of things like Java Web Tokens, JSON Web Tokens, not Java Web Tokens. Those would be big and slow. LDAP and certificate authentication, so you can do it with certificates. Vault can also act as a certificate authority, so you could generate the certificates with Vault, which then let you talk to Vault later, which is some kind of inception. But what we're going to look at is something called AppRoles. AppRoles are really easy to use because they're essentially usernames and passwords, but designed for services. So they're made of two parts, a role ID, which is the username, and a secret ID, which is the password. So let's look at how these are actually used in process. So I like to define what policies an application is allowed to use by embedding it into a configuration file in the repository. Now, due to my hatred of YAML, I use any other configuration language possible, including plain text files. In this case, it's just a TOML file with a Postgres connector and RabbitMQ connector. The Postgres connector was what we set up earlier with the different roles available to it. And when CI runs, it then updates Vault with something along the lines of this. It says, update this particular role name, and we have a role per application. And the policies it requires are the ability to connect to Postgres and the ability to connect to RabbitMQ. Now, this is a trusted process. The CI server is only allowed to do that update. It's not allowed to generate secrets or do anything else. It can only update roles. You don't have to do this. You could have them manually created yourself if you'd rather. But the advantage of having this stored in the repository is you've now got a single source of truth for where those policies are and what each application requires. Also means things go through code review pipelines, and you can do pull requests or have more sign-off required if you're modifying like security parts of your application. So like I said, it's optional, but it's a good idea. Once your build's done, you need to push your artifacts somewhere. Doesn't matter what you're deploying with. In this case, it's Spinnaker, but it could be Octopus or whatever Java people use. I don't actually know how you deploy a Java application. I think they escape. Like, they just escape into the wild and then they work, hopefully. But we give our artifact maybe a Docker container to Spinnaker, and we say, right, we need to deploy this somewhere. So Spinnaker will fetch a secret ID from Vault for that application. Spinnaker is only allowed to fetch secret IDs. It can't do anything else. It takes that secret ID and puts that into the application configuration and pushes it onto a server somewhere. Now we've got a password. It would be probably quite a good idea to have a username as well, because password on its own is not great. And in my case, I use Terraform to manage the infrastructure, and Terraform knows that given a role name, it can fetch a role ID, and it'll dump that into an environment variable on the host somewhere. Again, Terraform is only allowed to fetch role IDs. By having all these separate processes only allowed to do one part, no single part of my infrastructure has enough access to generate secrets and talk to the database. The CI server can only update roles. Spinnaker can only fetch secret IDs. Terraform can only fetch role IDs. The only thing that has all of the parts together to actually make a call is the application itself. So if Terraform gets compromised, you're in a lot of trouble, but at least it can't do everything and connect to all your databases. Now, if you're not using Terraform, that's fine. If you're using Chef or Puppet or Ansible or any other provisioning system, you can use that to fetch your role IDs. And if you're not doing automated infrastructure at all, you probably should be, but you could also just have the developer fetch the role ID and embed that into the application. Or you could have the CI do it. Marginally less secure, because now at the Spinnaker point, Spinnaker now has an application with a role ID and it has the secret ID. But it's easier to get started with. And while I want your application to be as secure as possible, I'm also aware that you can't just go completely to the secure end straight away. You need to get there in steps. And small iterations are less likely to explode things and go badly, so smaller iterations are better. So again, talking is boring, so I'm going to attempt to demo stuff again. So the next application is basically identical, except our configuration is now reading from environment variables and from a JSON file. Now, I have to actually pretend to be both parts of the application. I'm going to pretend to be Terraform and Spinnaker. So we'll set up AppRoles. So we're enabling the AppRole backend because it's not on by default. And then we create a policy. Now, this is the Postgres connector policy that we mentioned earlier. And it is allowed to read from the database credentials. So all policies in Vault are essentially a path, and then what actions you're allowed to do on that path. So in this case, anyone using the app role that we're creating is allowed to read credentials from the Postgres backend, but they can't write new configuration into it. We now create our role for the service. So unfortunately, you have a role and an app role, which gets a bit confusing. I wish they'd named it differently, but I'm not sure what else you'd call it. So our particular service, I've ingeniously called demo service, because I'm good at naming things. And as before, we specify that the tokens generated for this are going to take 20 minutes, and you're allowed to have them for up to 1 hour. And you're allowed to use the Postgres connector role, which is the one defined here. And now I'm pretending to be, this is a role ID, so I'm pretending to be Terraform. So I'm going to take this role ID, and I'm going to copy and paste it into my environment variables, somehow. Build, no, run. Edit configurations. Right, so app role access. And we have environment variables here. We'll do that. Hopefully. I can't see the save button. That's useful. hopefully enter saved that. I don't know. We'll find out in a minute. And now we're going to generate a secret ID as well. So now I'm pretending to be Spinnaker. Note that there's also a secret ID accessor. So if you want to be even more secure, you can modify your policy so that Spinnaker can't generate secret IDs, it can generate secret ID accessors, and then you give that to the application, and a secret ID accessor can be used once to fetch a secret ID. So by doing that, Spinnaker now doesn't have any knowledge of what the secret ID is, and the first time the application launches, it can use that accessor to get a secret ID, and if it doesn't work, someone's compromised your pipeline somewhere. But we're not going to worry about that because it's just more complexity that I don't want to deal with right now. And you can see here is my amazing configuration file. And now we're going to see if that actually worked. Fingers crossed. It did work. Excellent. And we can see here that our 3 roles, we've now only got 2 roles which are token readers, and 1 role which is app reader. That means that our first one that I generated on the command line has expired and been deleted. You can see that the other one's going to go in a minute. We can also see that the naming scheme of this, so the first part is token, or in this case, app role, and then reader is the role we requested. So if we'd requested writer credentials, then it would be v-approle-writer instead. And then a random GUID and a timestamp. So the only difference in this, go away. No. Oh my god, I love software development. Yeah, the only difference in this application is literally that we're reading some environment variables, and then in our connect function call here, we have the role ID and the secret ID which are coming from those 2 environment variables, and we're using those down here to talk to Vault. So rather than passing in the Vault root token, we're now using AppRole authentication methods. And just to show you that there are quite a few different ways of doing this, hopefully. Okay, these are all the different ways you can authenticate with Vault. Well, there's a Kubernetes one. There's a surprise. Yeah. So Radius and EC2, JWTs, Google Cloud, GitHub. There's lots of ways to authenticate. So chances are, whatever your organization is using for authentication, it's supported in here. So again, by using all of this, we're making now this configuration part, I tend to put in a shared library that our whole ecosystem uses, which means the developers of our system just have that bit to worry about. And maybe you'd say, here, you'd say reader, and pass in the reader role. So at this point, your developers just care that if I want to connect to the database, I call connect passing in what I want to do. Maybe I want to write a role in here. Or maybe you have another role which is migrator, which is allowed to make changes to your tables, and that might have a really short time to TTL. Like you're only going to allow that connection to be active for 1 minute, which would be fine until you had a transaction to update a gigantic table with 8 billion rows that takes half an hour. And I'm not sure if Postgres kills a transaction when the account expires or lets that transaction finish and then no more subsequent ones. So you'd have to take care of that yourself. What does happen if a transaction, if your account expires mid-transaction? I don't know. If you're going to do this in a time-sensitive application, you also kind of want to start using that token expiry part. So you put the connections into a cache in your code and say that when it's approaching expiry, get a new version so that you've got a new token and a new connection string available to talk to your database straight away, so you're not suffering the latency of a request coming into your API, and now you've got to round-trip Vault to generate a credential, and then you can connect to the database to answer their query. You'd make sure that there's always one available in the background. The last part we need to look at for this talk, which is on time-ish, is auditing. Now, like secret backends, Vault supports a number of different ways you can audit things. The 3 built-in ones are files, syslog, and sockets, Unix sockets. So you can send data to any of them. It logs all requests to Vault, and then all responses or errors. and you can enable multiple auditing backends at the same time. In fact, you should either have 0 or more than 1, because an auditing backend, if defined, at least one audit backend must successfully write to its log for Vault to answer a query. So if you request a token from Vault and you only have one auditing backlog enabled and it's a network share and that network share is offline, Vault will not give a token to the end user because it can't write to the audit log. Which makes sense because an attacker might want to switch off the auditing by blocking that network port, generate a credential, and then switch it back on again. So to block that attack vector, you must have a writable audit. Setting up an audit in Vault is nice and easy. This is the file one. I'm just writing everything to a Vault audit log. If you're on a file system like ext above ext2, so ext2, 3, and 4 support it, you can use the, I don't know how you say it, I call it chatter, the change attribute utility to mark a file as append only. So now no one can go back and delete things off that file either. But you could also push them to a network drive and take periodic backups, or do whatever you want, or have something listening to a socket and writing it into an append-only database. Really depends on what your auditing requirements are. Now I'm going to demo the auditing, and sneakily I already switched it on before I actually started the demo, so hopefully our audit file has got a lot of data in it. Let's look at it in VS Code, because that's a bit easier. Right, so go away, good. So each line is a line of JSON, and you can see that there's requests to the API and then responses. And let's just take the last one because that's not easy to read. JSON format. Nope. Right. So this is all the data that Vault logs. So we can see here that this is a response. So the response also includes the request made originally, but they're logged separately. So if a request was successful but the response wasn't successful, you've at least got that logged. We can see that the authentication was done with a token, which should be typed somewhere. Yeah, no. Token policy, yeah. So we've got the application that was doing the requesting. These are the policies that were in effect for that request, and that's the kind of authentication used. You can also see that the client tokens they used are there, but they're hashed already. So you can't take these hashes and get tokens back, but you could rehash the token and check that they match if you wanted. So the data's here, it's just not in a human readable form. We can see here that they requested a read from the database credentials reader path. They didn't specify any extra policies at the time, could have done, and they didn't specify any extra TTLs or anything else. And we can see that the response was a lease with this secret for a username and password which are hashed here. So again, if you wanted to take that password out of the database by querying it, you could then rehash it, and Vault will do that hashing. You can give it an arbitrary string of text and say, hash this, and get a result. So you can compare them as well. If there was an error, such as they're not authenticated to do this, then the error object will be filled in instead with a reason of why they weren't allowed. So this is something you can report on as well. And that was it for the auditing demo. So the goals of our upgrade to our software was to use unique credentials, which we've managed. We didn't bother going down to the user level of credentials. We just had services and applications. But we could quite easily extend it to have the individual authentication because all of our desktop users were authenticated with Active Directory. So we could integrate Vault into that as well. We no longer have any manual steps or scripts. Vault setup is technically a step, manual scripts, but that's managed by a different automated pipeline, out of scope for our developers. Stuff is securely stored. We don't have to worry about how Vault does the storing, we just know that it is secure. And I'm quite happy to chuck money at HashiCorp to make them liable for how well things are stored. It's auditable, as we saw. We had a file audit there, but again, we can push to a socket and have it written anywhere. And we didn't write very much code. There's literally creating a new Vault client using some authentication and then requesting secrets from it. And that minimal block of code is much better than writing a connection string to a file and then writing a decryption file and keeping the decryption key next to the file. I might as well have put the decryption key in the file, to be honest. Thankfully, we didn't. Yeah, so we could extend it with unique users, but we decided not to at this point because it was good enough for our needs. So again, there's a pragmatic approach to security. We could have done everything all at once, but the likelihood of everything all at once going successfully is quite low. And it turns out that to cover our security requirements, unique users are not really needed because we've already got logging of who the user is from other metrics, like what their workstation ID is and things like that. So, not necessary, but there if we want to expand to it. So I've got some links here available. Vault at the top. We've got some interesting information about how to do trust with Vault using AppRoles. This presentation is on the links, and the source code for the actual demo is on my GitHub as well. So that being said, what questions have people got? Or have I shocked you all into silence? No, there is a question.
What about configuration for high availability setup for Vault? Is there something?
Yeah, so the question is, what about Vault high availability setup? It depends what backend you're using to store. So Vault itself is stateless, but the backend store that you choose to store all your configuration in has to be high availability one. The options available for high availability are Consul, etc. I don't know how to say that one still. Etc. That thing. Cassandra, I believe, and maybe something else. Oh, in fact, let's have a look. Vault. Go here. The only downside is I'm never quite sure where the documentation is that I'm looking for. Let's try configuration. No. No. Button? Storage. Ah, there. Yes, I can read. Apparently not. Yeah, so you can click onto them and see, okay, so Cassandra is not high available. I mean, I can understand like MongoDB not being high availability, but okay, let's have a look at Postgres. No, that's... How is Postgres not... Yeah, so it depends what backend you choose, but the downside, if it's not high availability and it can't talk to the backend, you can't generate secrets. That's something else you need to look at when you're doing your secret lease times, is look at how long you can afford for Vault to go down. Because it shouldn't go down when it's a high availability mode, but it's possible. And if everything's depending on Vault, and you have, say, a maximum TTL on your connections of 5 minutes, you can only afford for Vault to be down for at maximum 5 minutes. But if you have a maximum TTL of, say, 3 months, that's probably a bit high. But Vault could be down for 2 months and 30 days, or 29, depending on which month it is. So you need to look at how long your TTLs should be. Probably a couple of days, or for a long-running service, or maybe 20 minutes is fine. But yeah, make sure it's high availability. The easiest thing to do is just to store things in Consul, because Consul is high available. And it's officially supported by HashiCorp, unsurprisingly. A lot of my talks involve HashiCorp. They don't pay me, but if they want to send me some hoodies or something, that would be nice. Anyone else? Yep.
So what's the difference in storing the Vault access key that can generate the secrets to database instead of just storing the password?
Right, so the question is, what's the difference between storing the Vault's access keys somewhere versus storing the password? And the point is that if we go back to Can I? Oh, I can. If we go back to this slide, is that when we write the secret ID into the application itself, that secret ID or the configuration file is only readable by that process, unless you've got administrative access to the server, in which case you've probably got other bigger problems to solve. So by keeping the two parts separately accessible, you're reducing the attack surface from that. But also those secret IDs are not permanent. They have a maximum TTL as well before you have to renew them. How you go about renewing them is quite a large topic in itself. You could do that with orchestration tools like Chef or Ansible, or you can have the application request new ones using its existing secret ID, but then you've got a secret ID that can request new secret IDs. So yeah, how you want to deal with this is an interesting question. If you're using something like Kubernetes or Nomad, you could just have your container die and build up a new version of the container that's got a new secret ID in it. That's the easiest way to deal with it, because it's complexity that you've pushed out of your software and onto your infrastructure. In Nomad, for instance, you can define your configuration object to have the secret ID in it, but you can say that when the secret ID expires, generate a new one and send a signal, such as restart or a custom signal, to the application to make it reload its configuration. So again, it's something you can push out of your software, but essentially it is the same as having the username and password stored, but because they're a shorter lifetime, it's less risky. Yeah. Yeah, so if an internal person can view your configuration files, that's bad, but you can solve that with Vault as well. So you shouldn't SSH to your servers directly, but you can configure a backend on Vault to handle SSH for you. So rather than me going SSH to production host 1, I say to Vault, I need an SSH connection to production host 1. It generates me an SSH connection to that server, connects me to it, and then it instantly revokes the access key. So the second I disconnect, I can't get back onto the server. And now at that point, you've got an audit log that I connected to the server. And now you can see that, this particular credential was used later, because that'll be in the audit log as well. This credential was used later to do something. Who had access to that? Oh, this person, or these people went onto that server, and now we can investigate who was on that server and why. And because the time window for how long a credential is valid for is quite short, hopefully you can correlate down to who did it. So yes, there is still risk, but it's all about minimizing the risk and trying to make a traceable thing. And if people know that everything's traceable and short time windows, then they know it's more risky to be naughty. And hopefully they won't be. And also, trust your employees. As a profession, we're quite expensive. So there should be some level of trust for us. Right. If no one else has got any questions or doesn't want to have me shouting random answers to them, I'll be around all day. Come and talk to me. So, thank you very much.